My name is Hamish Chaffer and welcome to this presentation on superposition in electric circuits. In this video, we'll explore what the superposition theorem is, see how it applies to both waves and circuits, and walk through a simple example of finding the voltage across the resistor using the principle of superposition. The superposition theorem states that any linear circuit with multiple independent sources, the total current or voltage in any part of the circuit is the algebraic sum of the currents or voltages produced by each source acting alone, with all the other sources turned off. In simpler terms, we calculate one source at a time, then add the effects together. For example, f of a plus b is equal to f of a plus f of b. Superposition isn't limited to circuits. It also appears in waves. Where two waves meet, they combine to form a resultant wave. That's the sum of their individual displacements. If two crests meet, they add up. That's constructive interference. If a crest meets a trough, they can cancel out. That's called destructive interference. The same principle applies to electrical voltages and currents. To further understand what superposition is, here is a short example of how it is used, where we find the voltage across R2 in this parallel circuit with three resistors, a voltage source, and a current source, where the top node is relative to the bottom node. First step of this process, we remove the current from the circuit and find the voltage on R2 from the voltage alone. Let's let the total summation of both R1 and R2 in parallel be RT of 1, which we find is 25. The total current of I1 supplied by V1 is equal to RT of 1 times the voltage, which is 25 ohms times 8 volts, which gives us 0.32 amps. Since R1 and R2 are in series, I1 flows through R2. The voltage across R2 due to V1 is then put back into Ohm's law to give us a final result of 2.88 volts in R2 from V1. For part 2 of this process, we find the contribution of the current source by adding it back to the circuit and removing the voltage source. Let I of R2 A1 be equal to the current of R2 from A1, which can be found by using the current divider rule, where A1 times R1 over R1 plus R2 gives us 2.56 amps across R2. This times the resistance that we are given can be put into Ohm's law to find the voltage of R2 from this second calculation. This leaves us with 23.04 volts. However, the polarity is positive on the bottom and negative on the top, since the current is flowing up. The final step of this process is a summation of values, where we know that V1 of R2 is equal to 2.88, and V2 of R2 is 23.04. However, is it a negative value since the bottom is a positive in this case and is top to bottom? Therefore, the total value of the voltage at R2 is a negative 20.16 volts. The superposition theorem helps us analyze complex circuits by focusing on one source at a time. We turn off other sources to solve for the variable of interest and sum of all contributions. It is a simple yet powerful method to understand how multiple sources interact in a circuit, and it connects beautifully to the same principle we see in waves, sound, and light. Thanks for watching.